Right. Which means then, if we take this expression and that one, plug it in there, differentiate it, the expression that we find, okay, let's do it, and then see what expression we find. So let's take that, put it in there. We are going to have, therefore, total energy is equal to half mx dot squared plus half k x squared. And if you differentiate this, of which I know, except those that saw me doing it, no one I know will be able to do that. It's very simple, but I know. I know people are not able to differentiate that expression. So I won't even ask you, I know it. And don't tell me you can't. Is there, in case there's someone who can do it? Who wants to do it? In case. Who wants to differentiate this with time? And let's see what they get. Who says they can do it? I know you do it in maths, but I know you can't do it in mechanics. You want to try? You were here last time. Yeah, because you saw me doing it. Who wants to try? Who says, I know I can differentiate this with time, because this is an expression of x dot, or of velocity, of displacement, and I want to differentiate it with time, and I want to find the solution. Who can do it? The one who didn't see me doing it. It's a challenge. Any takers? I've been teaching this for many, many years. A lot of years. Up to now, I haven't found someone who was able to do it. But it's simple because you do it in maths. So let's do it together. Right, this one, that's an expression of what? Of V, which is x dot. Let's do let's start with this one. We have fx is equal to half kx squared. dfx by dx is equal to what? We differentiate that with x, we get what? The 2 comes there, so it becomes what? 2 divided by 2, which is 1. Kx, ne?
Yes.
Kx. But unfortunately, what we want here is d et by dt. What we've done is in x. So what do we want? We want dfx by dt. And we can express this as dfx by dx. Then dx by dt. Same thing, auntie. We didn't change nothing. By dx, then the dx now is there, and dt. So this is the same thing. Are we together? Yes. In maths, you call it function of a function. Therefore, this is equal to this. We found a value, kx. Dx by dt. This is actually velocity. Can you see that? Yes. Because this is the rate of change of x with time. And our velocity, we write it in a smart way, that way, to show that is the first derivative. So this is simply kx x dot. So the idea, if you look closely, what have we done? You simply say for the variable there is the variable plus the next higher variable x, next higher variable x dot. Are we together?
Yes.
Now that I've told you, you can do it for the other one, eh?
Yeah.
Let's call it gx is equal to half mx dot squared. Who can tell me, someone who was not here, who can tell me gx by dt? From what we've said there, can you use induction to tell us the solution there?
dgx.
It's what?
dgx.
No, I mean the last one.
Oh, the last one.
The last value.
X dot into
Not people who know who. I want someone fresh. I want someone to think. I want people to think. Because that's what we must do all the time. Think. So if you've seen me doing it, you are not thinking. You are repeating. I want someone to think. Who wants to think and tell us the final result like this one?
The first one is mx dot, I think.
M?
X dot.
Uh-huh.
Let me see the second one. By...
You have finished and then you want to finish. You have finished already. And
By...
X dot dot.
someone here is shouting because he knows he was in the class. Now he wants to look smart. So that's what it is. You take the term and the next higher term. So you were right. You said X dot.